You'll recall that the input stream class was fairly high up in the hierarchy of inheritance, being just one step under the object class. So it's a pretty basic, pretty primitive class. It's used to read raw bytes from a file. We're going to look at the UML diagram and discuss it first of all. The read method reads the next byte from the file. A byte can range from 0 to 255 if we consider it to be an unsigned byte. For reasons that we won't get into right now, we could also interpret this as a signed byte, in which case we would say that it went from negative 128 to positive 127. But in the context of the read, it would definitely be considered a positive or unsigned byte, which would go then from 0 to positive 255. You'll notice that this method returns an integer, even though it's supposed to be reading bytes. Now, why do you suppose that is? Well, it's because we need some mechanism to use to indicate that there are no more bytes available in the file, and the mechanism we use is we return an integer whose value is -1. So in fact we always return an integer, but if the value of that integer is between 0 and 255, we can consider it to simply be a byte. However, if it's -1, it means that there was no more bytes available. You'll notice that's consistent with the rest of the read methods that exist in the class. The other two read methods read a number of bytes all in one foul swoop. If you've declared an array B of a specified number of bytes and you use that as a parameter, that many bytes will be read from the file and populate the elements of the array B. The alternative is to read with an offset and a particular length, indicating that you want to begin populating the bytes in that array at a certain offset, a certain index, and you want to read a particular number of bytes. There's an available method that tells you how many bytes are still available in the file to be read. And then there's a close method to close the file when you're done using it. And finally, there's a skip method that allows you to skip over and discard a number of bytes in the file. The output stream is the counterpart of the input stream that we just talked about in the previous slide. You'll notice that there are three write methods, and they're similar to what we saw before in terms of being able to write this time an entire array or a portion of array starting at a particular offset and specifying a particular number of bytes, or simply writing a single byte all by itself to the file. The latter of those, that is writing a single byte to a file, is accomplished by passing an integer argument, but of course it's treated as though it were a byte. So in other words, it's cast to a byte. There's also a close method like there was with the input stream, and finally there's a flush method, and what that does is it takes any bytes that you've indicated should be written but may have not necessarily gotten written out to the disk and flushes them all out to the disk. You might wonder how that can happen. Well, just because you write doesn't mean it actually physically went to the disk. I/O tends to be buffered in most operating systems and languages, so what that means is when you do the write, it's really preparing it to go to disk, but not necessarily going to disk. When you do a flush, it actually makes sure that anything that you've written up to that point is physically put out to the disk file. It's noteworthy that if you're using a file to capture results while you're debugging, make sure you flush, because if your program crashes and you haven't flushed, then what you see in your output file that you might be using for debugging purposes might not accurately reflect how far your program actually got. So if you're going to debug using files to indicate how far your program got or certain intermediate results that were generated, always flush, so that if your program does crash, you know that what is in the file actually does represent everything that you attempted to write. One level of inheritance down from the two classes we just finished talking about are the file input stream and file output stream. These classes associate the input or output streams that we just finished talking about with a particular file. In order to construct the first of these objects, the file input stream, we have two different constructors. You'll notice one of them accepts a string file name and the other takes a file object. the file output stream object is a little bit more sophisticated. It still can accept a file name or a file object, but you'll notice it optionally allows you to have a boolean as a second argument in either case, and that boolean is either true or false to indicate whether we want to append or not append to an existing file. In other words, if the file doesn't exist, then that parameter becomes completely irrelevant. But if a file does exist, then the question arises, would you like to append to the end of what's already in the file, or would you like to scrub the file and start over? If this Boolean parameter is true, then you're going to just continue writing to the file without erasing what's already there. In other words, you won't overwrite. On the other hand, if that parameter is false, then that would indicate that you want to scrap what's in the file and overwrite it.